Alright guys, in this video we're going to be looking at some of solids and the properties of solids and some questions that go with those. So here's like a multiple choice question. Which of the following best explains how the bonding in metal allows it to be ductile? Ductile means it's allowed to be drawn into a wire. So looking at these choices, metal atoms are spherical, therefore the solid can be easily drawn into wires that have a round cross section. Okay, not really true. Like atoms aren't spherical. They have like a spherical shape, right? But they take on lots of different shapes based on those orbitals that they have and the way that they bond. But not really a good answer right there. Because the strong directional bonding in solid metal, the atoms both in front of and behind of an atom give it a wire will bind together more strongly than the atoms not along the direction of the wire. Okay, the reason why this is wrong is this part right here, strong directional bonding. Okay, in a metal, right, those electrons are free to flow throughout the metal, and we don't have this strong directional bonding, and rather it's just kind of like a sea of an aqueous of electrons that float through around, and so those metal atoms aren't really strongly directionally bonding. C, because the mobile electrons attract the metal cations equally in all directions, the metal cations can easily move past one another as the metal is drawn into a wire. This is definitely the right answer. It gives a good definition of what a metal is, how they work. Look, we've got mobile electrons, we've got metal cations, they're equally in all directions. This is just the correct definition, so it's probably going to be C. And D, metal atoms tend to be much smaller than non-metal atoms, therefore they can move easily past one another as the metal is drawn into wire. Okay, this isn't a true statement. Non-metals are actually smaller than metals. Most non-metals are. And so because of that, it's already a false statement. We're looking for the one that actually creates a true statement about metals and bonding. And C is just the only one that's actually correct. So that would be our answer there. This short answer, we have two ionic compounds, NaCl and MgS, and they're represented in the diagrams above. Which statement correctly identifies diagram 1 and identifies the compound with the lower melting point? We have to explain why. Okay, so looking at each diagram, we'll notice diagram 1 has two ions. It'll either be NaCl or MgS. And these seem to be roughly closer in size than these two. These two seem to be different in size, okay? Or more different in size compared to diagram 1. So we need to compare the sizes of NaCl and MgS. Now, NaCl, when they form a bond, right, that turns into Na plus and Cl minus. And when MgS forms a bond, that's a +2 charge and a -2 charge. We have to keep those in mind when we determine size. Because as we remove electrons and add electrons, we are increasing the nuclear charge, the effective nuclear charge on these atoms, and that will tighten up atoms it will tighten up the atoms. So in reality, it looks like if we look on the periodic table, where they're placed on the periodic table, we got Na, Mg, S, and Cl. Based solely where they are, we would say Na and Cl have a bigger difference in their atomic radius, whereas Mg and S should be closer in radius. But instead, it's the opposite because now we have this increased nuclear charge. Mg and S are actually going to be much different in size compared to NaCl. So diagram 1 is NaCl, and diagram 2 is MgS, okay? There's a bigger disparity in size with MgS versus NaCl. So that is diagram 1, okay? And then it asks us to identify the compound with the lower melting point and explain why. So a lower melting point means we're going to have weaker ionic bonds that we're breaking. So between NaCl and MgS, I'm going to say NaCl. Okay? NaCl has these single charges holding them together in that ionic bond, whereas MgS have +2 -2 charges holding it together. So they have a stronger ionic bond. So right here, it actually has the answer for us, and it's written out really well. Diagram 1 represents NaCl. It has a lower melting point than MgS because the Coulombic attractions between a singly charged Na plus ion and the Cl minus ion are weaker than those ions in MgS. So this is a good written out answer for that one.